Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In our third meeting in airport design class, we will discuss about the runway length. This is an intersecting runway at Brussels Airport at Belgium. As you can see, this is the intersection of the runway, and the biggest question for our meeting is how we design the length of the runway. As an airport engineer, we should have to consider what factors that may affect the runway length, so we can determine the length of the runway. These are the factors that affecting the runway length. So there are 4 factors. The first is the performance characteristics and operating masses of the aircraft to be served. So actually for the performance characteristics, we will discuss in our next meeting, but I will talk about this a little bit. So the performance characteristics is about the engine cases. So there are 3 cases. The first is normal takeoff cases. The second is the engine failure cases, because sometimes the takeoff or the landing is not happened and because of the engine failure. And the third is the landing cases, but we will discuss about it in next meeting. So the second is the operating masses of the aircraft. So the weight of the aircraft affecting the runway length too. The second is weather, particularly for temperature and surface wind. So the aircraft takeoff or landing in higher temperature or lower temperature, it may affecting the runway length and also the surface wind. The third is runway characteristics such as slope and surface condition. So the aircraft take off or landing in a downhill or in an uphill, it may make a different runway length. And the surface condition, like is the runway wet or dry, it also affecting the runway length. And the last is for the airport location factors. For example, the airport elevation, which affects the barometric pressure and topographical constraints and obstacle near the airport. So how high the airport elevation, it will affect to the runway length. And also if there any obstacles near the airport, it may also affecting the runway length. So the second, the third, and the fourth, we can call them as environmental impact that affecting the runway length. So in this meeting, we will discuss about it more. Now, let's talk about the aircraft weight that affect the runway length required. So, the greater the total weight of aircraft weight is, the longer runway length required by an aircraft to take off or landing. The definition of the aircraft weight is the OWE, or operating weight empty, plus payload the passengers, the cargoes, and etc., plus fuel. Or we can also, the aircraft weight is the MTOW, the maximum takeoff weight. So this is the same like the people that have more weight, they should have to release the energy more than the people that have less weight when they have to run, or they have to walk, or they have to do many activities. They have to release more energy than the people that have the less weight. So this is the same like the aircraft. Next, we will talk about the environmental impact they affect the runway length that required to aircraft to take off or landing. So we will discuss about the 6 environmental impact. The first is the temperature, the second is the surface wind, the third is slopes, the fourth is runway surface condition, the fifth is the elevation, and the last is obstacles near the airport. First we will talk about the temperature. So the higher the temperature, the longer runway length required by an aircraft to take off or landing. So when an aircraft take off or landing in a higher temperature, so it needs the longer runway length by an aircraft to take off or landing. Why? Because the higher temperatures will create low air densities, resulting in lower output of thrust and reduced lift. So it's about the air densities that will lift up the aircraft when it take off or landing. The second is the surface wind. In the surface wind, we will talk about the headwind and the tailwind. The greater the headwind down the runway, so the shorter runway length required by an aircraft to take off or landing. In contrast, the greater the tailwind down the runway, the longer runway length required by an aircraft to take off or landing, because the headwind will help the aircraft to lift up. It is in contrast with the tailwind. So this is about the surface wind that may affect the runway length required by an aircraft to take off or landing. Next, we will talk about the slopes. So if an aircraft take off or an uphill gradient, so the longer runway length required for aircraft to take off or landing. And also in contrast, an aircraft that take off on a downhill gradient, it takes the shorter runway length required. Next is the runway surface condition. So if an aircraft take off or landing on wet runway, so the longer runway length required, but this is especially on landing. Next is the elevation. So the higher elevation of the runway, the longer runway length required to an aircraft to landing or take off. The next is the obstacle. The presence of hills or other obstacles near the airport it may take the longer runway length required for aircraft to take off or landing. So after we know the factors that affect the runway length required by an aircraft to take off or landing, we will know that every airport have has the different runway length because it have the environmental effects that difference from one to another airport. So first we have ARFL. ARFL is the aeroplane reference field length. Actually we will discuss about it in next slide, but in this slide I will explain the ARFL as the basic length of the runway. So maybe for some airport have the same ARFL depend on the aircraft, the maximum aircraft that served by the airport. So this is the ARFL or the basic length of the runway. But if we have three kind of environmental effect for the aircraft and of course the runway, from the elevation, the slope, the temperature, is different in every airport. So it will make a correction to the ARFL or the basic length, so it becomes the actual runway length, and it's different in every airport because of this environmental impact that may different in every airport. So we will discuss about the ARFL. ARFL is the aeroplane reference field length, or it's defined by the minimum field length required for an aircraft to take off, and it is also called by basic length. So every aircraft have different ARFL. So the ARFL is calculated at maximum certificate takeoff mass, sea level, standard atmospheric conditions, still air, and zero runway slope. Or we can define all of this as zero elevation, standard atmospheric, or about 15 degrees of Celsius, zero wind, and zero runway slope. So this is the calculation of the ARFL in these conditions, but we also know that it is impossible or it is hard to find an airport that have all of these conditions. So like I said before, that there was the correction for the ARFL to make an actual runway. So the ARFL we can see in the aeroplane flight manual that's given by the aeroplane manufacturer, like I said in the last meeting. So the aeroplane characteristics is different for each aeroplane type, of course. So for example, if we have the maximum aircraft that served by an airport is Boeing B717-200, so the ARFL or the minimum field length required for takeoff is 2,130 meters. So this is the ARFL. So the biggest airport, the biggest ARFL required to take off or landing. Now, after we talk about the ARFL, or the basic length of runway that required by an aircraft to take off or landing, we will discuss about the runway length correction. The runway length correction is depend on the environmental items that every airport has. So for the first corrections is for the elevation. The basic length selected for the runway, or this is the ARFL, the ARFL should be increased at the rate of 7% per 300 meters elevation, or for the formula is the FA equals 1 plus 0.07 multiplied by h per 300, or the FE is elevation correction for runway, and the h is the airport elevation. So this formula, we will use it when we calculate the corrections for elevation. The second is the slope, where the basic length determined by takeoff requirements is 900 meters or over. So for the takeoff requirements is the length of the runway is 900 meters is the minimum, or over is by the ARFL, that length should be further increased at the rate of 10% for each 1% of the runway slope. So the formula is the FG equals 1 plus 0.1 multiplied by G. So the FG is the slope correction for runway, and the G is the runway slope. Next is the temperature corrections for the runway. The length of runway determined, or the ARFL, should be further increased at the rate of 1% for every 1 degree of Celsius. If, however, the total correction for elevation and temperature exceeds 35%, the required corrections should be obtained by means of specific study. So for the formula is the FT equals 1 plus 0.01 multiplied by TR minus 15 minus 0.0065 multiplied by H. For the FT is the temperature correction for runway, and TR is the airport reference temperature, and H is airport elevation. So this formula we will use as the corrections for the runway because of the temperature. And For the TR, or the airport reference temperature, we will also find with this formula. The TR equals TA plus a third multiplied by Tm minus TA. The TR is airport reference temperature, the TA is average daily temperature in amount, and Tm is the average of maximum daily temperature in amount. So for this calculation, we will have an exercise in the next slide. So the table below gives the information about daily temperature in the hottest month, June, in an airport. So find the airport reference temperature, or TR. So this is the day in a month. So June has 30 days, and this is the maximum daily temperature. So for example, 34.5 is the maximum daily temperature in day 1, and this is the average daily temperature. So the average daily temperature in day 1 is 30.5. So for the total, the maximum daily temperature in June is like this, and for the total of average daily temperature in June is like this. So we will calculate the airport reference temperature. So the Tm is the average of maximum daily temperature, so it is 1 divided by 30 because there was 30 days in June, multiplied by maximum daily temperature, the total of maximum daily temperature, or 1069.6, and it is equal by 35.65 degree of Celsius. After we get the Tm, we will look for the TA. The TA is the average of average daily temperature, so it is 1 divided by 30 because there was 30 days in June, multiplied by the total of average daily temperature here is 936.9 is equal by 31.23 degree of Celsius. So after we get the Tm and TA, we will look for the TR, or the airport reference temperature. So the TA plus 1 divided by 3 multiplied by Tm minus TA, and like this. TA we get from here, Tm we get from here, and TA we get from here also, and we calculate it. So the TR, or the airport reference temperature, is 32.7 degree of Celsius. So this is how we calculate the airport reference temperature. But sometimes we don't have to calculate this because it is given in the question, so we don't have to calculate this if we has given the airport reference temperature in the question. Here is the example of the application of runway length corrections. So the data given is runway length required for landing at sea level in standard atmospheric condition is 2,100 meters. The runway length required for takeoff at a level site at sea level in standard atmospheric conditions is 2,500 meters. As for the airport elevation, is 150 meters. The TR, or the airport reference temperature, is 24 degrees of Celsius. The temperature in standard atmosphere for 150 meters is 15 degrees of Celsius, and the runway slope is 0.5%. So please find the actual runway length. So here is the answer. First, we should have to define the ARFL, or the basic length of the runway required by aircraft to take off or landing. So we use the 2,500 meters because the runway length required for takeoff, or the ARFL, is 2,500 meters. So after we define the ARFL, or the basic length, we will calculate the runway length corrected for elevation, slope, and temperature. So for the first is runway length corrected for elevation, we use the formula of FE. The FE is 2,500, this is the ARFL, multiplied by 0.07 multiplied by the airport elevation is 150 divided by 300. So these are from the formula. Is equals by 1.035. The second, we will calculate the runway length corrected for slope. So we use the formula of the FG is 1 plus 0.1 multiplied by 0.5 for the runway slope. So we get the 1.05. Third, we will calculate the length corrected for temperature. We will use the formula of FT. So the FT is 1 plus 0.01 multiplied by 24. The 24 is the TR, or the airport reference temperature, minus 15. The 15 is the temperature standard atmosphere, so 15 degrees of Celsius, minus 0.0665 multiplied by 150. So we get the 1.099. So after this, we will calculate the actual runway length. The actual runway length is the ARFL, or the basic runway length, multiplied by FE, FG, and FT. So the ARFL is the 2,500 multiplied by FE is 1.035 multiplied by FG, 1.05 multiplied by FT, 1.099. So we get the actual runway length is 2,986 meters.